You're about to pump gas, but 3 invisible mistakes are already costing you money. Most drivers make at least one of these errors every single time they fuel up. The difference, some lose a few miles per gallon. Others end up with a $2,000 repair bill they never saw coming. Therefore, understanding what actually happens during those 5 minutes at the pump could be the difference between the car that lasts 200,000 miles and one that's dead at 80,000. I'm going to walk you through the 7 deadliest gas station mistakes. But here's what makes this different. We're showing you exactly why each mistake destroys specific parts of your fuel system and how to protect yourself starting today. Picture this scenario. You start pumping gas, set the automatic latch, then slide back into your car to check your phone or escape the cold. But the moment you sat down and stood back up, you turned your body into a walking spark generator. When you moved across that synthetic seat fabric, electrons transferred to your clothing. You're now carrying several thousand volts of static electricity. Modern fuel pumps are grounded specifically to bleed off static as fuel flows through the system. Therefore, when you were touching the nozzle, you were part of that safe, grounded path. The second you let go and re-entered your vehicle, you broke that connection. Now you're walking back to grab a metal nozzle, pumping gasoline vapor into the air. Gasoline vapor ignites at concentrations as low as 1.4% in air. Right around your filler neck, that perfect mixture exists in a cloud you can't see. The spark doesn't need to be visible. A discharge of just 0.2 million joules can ignite gasoline vapor. When these fires start, they escalate in seconds. Drivers instinctively yank the nozzle out, spraying burning fuel across the car's body panel and onto the pavement. But there's a simple solution. If you must get back in your car while pumping, always touch a metal part of your vehicle away from the filler area before touching that nozzle again. Static kills fast, but the next mistake kills slow. The pump clicks, your tank is full, but you squeeze the trigger again to round up to an even dollar amount. This single habit is quietly destroying your car's evaporative emission system. Modern vehicles use a sealed evap system with a charcoal canister designed to capture fuel vapor, not liquid gasoline. When your tank reaches the correct fill level, there's deliberate space left above the fuel. Therefore, when you force extra fuel in after the first click, liquid backs up into the filler neck and gets pushed into vapor lines, leading directly to the charcoal canister. Activated charcoal works because it's incredibly porous, but once liquid gasoline saturates those pores, the charcoal stops filtering vapor and starts acting like a soaked sponge. Symptoms start small. The pump clicks off repeatedly during your next fill-up. Fuel burps back out. You smell gasoline. Then the check engine light appears with an evap system fault code. Replacing a saturated charcoal canister, vent valve, and damaged vapor lines runs between $400 and $1,200. The worst part, you caused it by adding 3/4 of a gallon you didn't need. Stop at the first click. Always. You pull into a station while a tanker truck is still connected, or just minutes after it's driven away. Those massive underground tanks just received thousands of gallons pumped in at extremely high flow rates. Therefore, everything that settled to the bottom over the past week just got stirred back into suspension. Rust particles from aging steel tanks, sediment, water that condensed inside the tank. The fuel pickup tube sits slightly above the tank bottom by design, but a fresh delivery temporarily turns the entire volume into a contaminated mix. From your fuel system's perspective, that debris load hits your fuel filter much sooner than expected. Particles that slip through move toward injector screens. Modern direct injection systems operate at pressures exceeding 2000 PS. A microscopic particle can partially block an injector, distorting the spray pattern and creating incomplete combustion. You feel this as rough idle and hesitation, but by the time symptoms appear, the damage is already spreading. If you see a tanker present or the fill port covers are still wet, wait 20 to 30 minutes. Clean fuel starts with calm underground tanks. You stretch it one more day with the fuel gauge below E and the warning light glowing. On most modern vehicles, the electric fuel pump sits inside the tank, submerged in gasoline for a very specific reason. Fuel provides cooling, lubrication, and a steady supply at the pump inlet. When fuel levels drop very low, more of the pump sits exposed to hot vapor instead of liquid. The pump motor overheats. Therefore, Repeatedly driving with extremely low fuel shortens pump lifespan by hundreds of hours. But there's another problem. Fuel tanks accumulate fine debris over time. Rust particles, dust, rubber fragments from deteriorating hoses. All of this settles to the lowest point. When your fuel level is near empty, the pump draws from exactly that area where sediment concentrates. Modern fuel pumps cost between $400 and $800 for the part alone. Labor adds another $200 to $600. Refuel at around a quarter tank. Keep the pump submerged, cool, and drawing from cleaner fuel layers. You find a plastic gas can that's been sitting in your garage for 6 months. Instead of properly disposing of it, you dump the entire contents into your tank and top off with fresh fuel. Fresh gasoline is a precisely engineered blend. But gasoline isn't chemically stable. Over time, especially in vented containers exposed to heat and air, oxidation begins. The lightest components evaporate first. Gums form. The octane rating drops. Lab testing shows gasoline stored improperly can lose 3 to 5 octane points in just 6 months. Therefore, when you pour that entire can into your tank, especially the last few ounces where contamination concentrates, you're sending the worst part directly into your fuel system. Modern engines are calibrated tightly around minimum octane requirements. Lower the octane significantly, and the NOx sensor intervenes. The ECU pulls ignition timing. Your car feels noticeably weaker. But the oxidation byproducts cause another problem. They coat injector tips and intake valves with a varnish-like residue. Old gasoline should be treated as hazardous waste. Pouring it into your car just spreads damage. Most drivers keep a portable gas can for emergencies, but using the wrong container turns a helpful tool into a contamination source. Approved fuel containers are made from specific plastics designed to resist gasoline solvents. Many everyday containers are not. Thin water bottles, soda bottles, or cheap household jugs soften, swell, or become brittle when gasoline touches them. A bottle that's perfectly fine for water can leach plasticizers, dyes, and microscopic plastic fragments once gasoline fills it. Any particles not stopped by your tank strainer move to the fuel filter. Finer debris reaches injector. Modern direct injection systems demand extreme precision. A particle invisible to your eye can partially block an injector opening. The result is prematurely clogged fuel filters, noisy fuel pumps, injector fouling, and partial blockages. Only one proper certified fuel can eliminate this entire risk. After refueling, you twist the cap until you hear 1 click, maybe 2. Then you drive away. But your car's evaporative emission system expects that cap to be perfectly sealed. Modern vehicles perform regular self-tests where the ECU applies slight vacuum or pressure to the entire fill system. The system monitors how well that pressure holds. If pressure drops too quickly, the computer logs an evap leak code and illuminates your check engine light. A gas cap that isn't fully tightened creates the same pressure leak as drilling a hole in your sealed fuel system. Therefore, you'll see that check engine light within miles of leaving the station. But the consequences go beyond just a warning light. A loose cap allows fuel vapors to escape. It also allows humid air, dust, and road grime to move in and out of the tank. Moisture condenses on cooler metal surfaces, promoting internal corrosion. Loose gas caps send owners down expensive diagnostic paths. Shops replace purge valves for $150, vent solenoids for $200, sometimes even charcoal canisters for $600 or more before someone finally checks the cap. Therefore, the solution costs nothing. Tighten your gas cap slowly until you hear at least 3 distinct clicks. That sound confirms the seal is fully engaged. 3 clicks. Every time. It's the cheapest maintenance you'll ever perform. You now know the 7 gas station mistakes that destroy cars and drain wallets. But knowing isn't enough. The test comes next time you pull up to a pump. Will you stop at the first click? Will you stay out of your car while fueling? Will you tighten that cap 3 times? These tiny habits create massive differences. Some drivers get 200,000 miles from their fuel system. Others face breakdowns at 80,000. The choice is yours. Make it count.